Good morning, one and all. In today's lecture, also we'll see the cantilever beam numericals. Okay, today we'll complete this cantilever beam part. Okay, see this cantilever beam is given having the couple is at the point A and at the point C. Okay, and some point load is at point B and C. Okay, and distance is given 2 meter, 2 meter and 2 meter. And how to solve this numerical? You know that. First we want to calculate the support reaction. Okay, support reaction. How to calculate the support reaction? Here we will consider the support at point D, also moment at point D. Okay, we will calculate first summation of Fy is equal to 0 at point D. Check that. Here we will consider the support at point D is the RD, reaction RD. This is vertical direction or upward direction. That's why positive. Then this support is acting downward direction. Don't consider the moment when you find out the summation of Fy is equal to 0. Okay, because think about only the load. Okay, RD minus 20, then minus 40 is there, is equal to 0. Then you will get the RD is equal to what? 60 kilonewton. RD is equal to 60 kilonewtons. Similar way, we want to consider the moment or couple at point D in clockwise direction. We can say this is the moment is a MD. MD is there. Okay, we will calculate that summation of MD is equal to 0. Summation of MD is equal to 0. We will consider clockwise positive. We will consider the clockwise positive. Then check that we are consider the moment at point D is equal to 0. Summation of MD is equal to 0. Then we are coming left to right. We are coming left to right side. Okay, see there is a which point is here is a one movement is that we are consider having that movement is a clockwise direction. That's why plus MD. Okay, at point C there is one movement is at in the clockwise direction again. I will write the plus then. Okay. Then here is a one movement is at point A in anti-clockwise direction minus 20. Then see this point load is also converted into the moment. How to convert this? Force into distance. How much force is at 20 kilonewton? Okay, this is going anti-clockwise direction. Check that, anti-clockwise direction. That's why we are moving left to right. Minus 20 into distance up to the D point C to D, 2 meter is there. Minus 20 into 2 is there, and this one again this is going anti-clockwise direction. Minus 40 into distance up to the B to D is 4 meter. Minus 40 into 4 is equal to 0. Then if you have calculate this MD, check that, plus 10 minus 20, then minus 40, then minus 160 is equal to 0. If you have calculated then MD is equal to, you will get the positive 210 kilonewton meter. This is the value of that moment. MD is equal to 210 kilonewton meter is there. Okay. Then we want to find out the shear force calculations. Once you will calculate the reaction, support reaction, you will get RD is equal to 60 and MD is equal to 210. RD is equal to 60 kilonewton. Then calculate, then do the calculation of SF. SF calculation. How to do the SF calculations? You know that SF calculations. Okay, we are consider only the load, vertical loads. Okay, first SF at point A, check that there is no any load, only the movement is at. That's why I will write SF at point A 0. At point B there is a load is at. That's why you will get the 2 points. Except at B, just left side. Just left side again 0. Then except at B, just right side. If you are coming the just right side, then there is a 40 kilonewton is at in downward direction. That's why you will get the minus 40 kilonewton. Then except at C, there is again point load. That's why you will get 2 points at C point. Except at C, just left side, there is again same load minus 40 kilonewton. If you are coming the just right side, then check that except at C, just right side minus 40. Again this load is at downward direction minus 20. Means you will get the minus 60 kilonewton. Right? Then last point, except at D, just left side. Just left side again you will get the same minus 60 kilonewton. And if you are coming the just right side of that, this minus 60 and RD again we have the plus 60, you will get the 0. That's why first and last point you will get the 0 load. Okay, then we will draw the SF diagram. Check all the value we are getting the negative. That's why I will draw here one 0 line at A, B, C and D point. Check that SF at A 0. Right? Remember that if there is a no load is at, if you are getting the value is a 0, then you should draw the horizontal line. Means there is no load. Okay, in the SFT remember that if there is no load, then you have to travel on the 0 line, straight line. And SF at B, just right side minus 40. Means we are coming the downward, right? At point B, just we are coming the downward. This is the 40 kilonewton. Then SF at C, check that just left side again minus 40 kilonewton. There is no load, that's why we will travel the horizontally or straight line again 40 kilonewton. Then again check that SF at C, there is a 2 point. We will get the right side minus 60. And we are coming the downward again minus 60 kilonewton. Then C to D, no load, we will travel the straight. Then 60 kilonewton. And except at D, just right side, we will get the 0. Then you will get the negative shear force diagram S and D. Okay. Then how to do the BMD calculations? Very simple. Similar, you have to consider the movement and convert the point load into the movement. Then BM calculations, check that BM calculations. What is the bending moment at A? Where is the moment is at? There you will get the 2 points, right? Bending moment at A, just left side 0. Okay. And if you are coming the just right side, bending moment at A, just right side, check that here is the anti-clockwise movement is at. We are coming here, then we are consider the minus 20 kilonewton meter. Then next, bending moment at B point, just left side. There is no any load, that's why you will get the same answer, minus 20 kilonewton meter. If you are coming, at point B, not left and right, at point B, because there is no movement. Then bending moment at C, there is movement is at. Again you will get the 2 point, left and right. Bending moment at C, just left side. Check that. This minus 20 and one more load is at. This load is going anti-clockwise direction. Anti-clockwise direction means minus 40 into 2 meter. Minus 40 into 2 meter. You will get this 100 minus 100 kilonewton. Then bending moment at C, just right side. Okay, we have calculated up to the just left side minus 100. You will get the same distance again if you have calculated. That's why take this value minus 100 and consider the moment is at clockwise direction plus 10. Then you will get the minus 90 kilonewton meter is there. And last point, bending moment at D point, Again here is a one movement is that, right, at the point of D. Check that. Just left side and just right side. Check that. Just left side we are considered up to this. Then you will get minus 20. Then again this minus 40 into distance up to the D, 4 meter. Then minus 20 into up to the distance D, 2 meter. This plus 10 clockwise movement is that. Plus 10 clockwise movement is that. You will get the minus 210 kilonewton meter. Okay, and here you will get the, already we have calculated MD is a 210. Bending moment at D, just right side, this minus 210 and plus we are coming that side, then you will get the 210 positive, you will get the 0. Then you can draw the bending moment diagram with that of that calculations. See all the value we have the negative value. Then we will start from here. At point A, B, C and D. Take that bending moment at point A, 0. 0 is there. Okay, we will start from there, left side and right side. Bending moment at point A, right side minus 20 kilonewton. Okay, at point A, check that, minus 20 kilonewton. Here, if you are getting the 0 line, okay, 0 shear force, then you should travel the horizontally. Take that first bending moment at A point, here is a 20 kilonewton meter. Then at point B, we have the same value, minus this value, minus 20 kilonewton meter is there. Then we travel the horizontally. Okay, don't do the mistake here, don't draw the inclined line. Okay, because here is a shear force is 0. If the shear force is 0, then you should draw the horizontal line in the bending moment diagram. Remember this. Then next bending moment at C point, just left side minus 100 kilonewton. Here we have drawn the horizontal line. Here we draw the inclined line. We are coming the downward. This 100. I will write here 100 kilonewton meter is there. At C point, just left side, and right side again minus 90, means we are going the upward direction. Here is a minus 90 kilonewton meter. Okay, because there is movement is that's why we will get the 2 points. Bending moment at D, just left side. Check that again, we have the value minus 210. Suppose here is a minus 210. And we will draw the incline because here is a horizontal line. 210 kilonewton meter. And bending moment at D, just right side, you will get the 0. This is the BMD. This is the bending moment diagram. Don't confuse guys, because why I have taken this numerical, because here is a movement is that, some movements is that. Okay, if the movements is that, then how to do the calculation of SF and BM diagram, or how to draw the BM diagram? If you are getting the zero shear force, this is very important. Okay, today we'll stop here.